All right, well, let me go over a couple of things here before we finish up section 4.3. Here are the answers to last night's homework, and some of this is a little bit different, so I want to make sure we go over this. So just take a look at what you got, fix what you need to, and then just make sure they're correct. So the first ones were from 239, number 5, and then 7 through 14. So on that page, here's number 5, and it asks you to write each relation as a table, a graph, and a mapping diagram, and they give you a set of ordered pairs. And now typically what we want to do is put the x's in order. And so -7 goes to 7, -3 goes to 3, -1 goes to 1, 5 goes to -5. And then you have the graph right here. The mapping diagram tends to be the one you're least familiar with. And what we want you to do is put these in order. So if I put -7 here, I put -3, I put -1, and then 5. Those are my domains. Ranges are your y values. That's going to be, and I'm going to put those in order, -5, 1, 3, and 7. All right, you need to draw an arrow. As you see, it has to have an arrow on one end, and it always goes from domain to range. So -7 will go to 7. -3 goes to 3. -1 is paired with 1, and 5 is paired with -5. It's okay if those lines cross. They're not always going to look like this one here. Now, on the others here, 7 through 14, don't worry about number 6. You didn't have to do that one. All right, so for 7, when they list the ordered pairs, you need to list the domain and ranges individually. So that you list it as -5, 0, 2, and 5. Your range would be -20, -8, 0, and 7, and put in order. Okay, just don't list them however they come. Make sure you put them in order. And here's your domain: 1, 2, 3, 4, 5 for 8, and 2, 4, 6, 8, and 10 for the range. So 9, and let me do this. Okay, 9 is very similar. They list a set of ordered pairs, so you would list them out. However, for 10, it is a graph, and you want to go from the smallest to the largest. So when it's a graph, we're going to use this notation here we talked about yesterday. 0 is less than or equal to x, is less than or equal to 3. Our range is 0 is less than or equal to y, is less than or equal to 3. Now for 11, they add an extra step. It says give the domain and range of each relation and tell whether the relation is a function, and then explain. The explain will be the hardest part, and it's what you also need to be able to do. Okay, so the first one, the domain is 1 because that is the x value of all of them. And then range is -2, 0, 3, and 8. It is not a function because the domain is paired with more than one range value, actually several. So if you see how they're listed, you got the ordered pair 1, -2, and we got the ordered pair 1, 0. Once the number 1 goes to two different numbers, it is not a function. So you can say one domain goes to two ranges or more than two ranges. All right, number 12, -2, 1, -1, 0, 1 is your domain. Range is 1, 2, 3, and 4. It is a function because each domain is paired with exactly one range. 13. All right, you got to watch this one because everything is -2 and the y value is 1 on all of them. Oh, why is that not writing? It's not writing for some reason. Whoops, I didn't want to do that. Well, hold on a second. I'm going to pause this and see if I can figure out what's going on. All right, not really sure what happened there, but hopefully we got that fixed. Like I said, with 13, that can be a little bit confusing because you got -2 paired with 1. You got -1 paired with 1. They're all paired to 1. So do not list all those ones as your range. Just list the number 1. It is a function, and here's why, because each member of the domain only goes to a one member of the range, and it doesn't matter that repeats. It only is not a function like if -2 goes to 1 and then later on -2 goes to another number. That is not a function. And it's okay if different x values go to the same y value. All right, 14, here's your picture. This is a graph. Okay, so usually when you have a graph, we're going to end up using this notation here. -3 is less than or equal to x is less than or equal to 3. Go to the furthest point on the left, the furthest point on the right, and as long as that is continuous, doesn't matter if it moves up or down, it hits everything in between -3 and 3 on the x-axis. So that's how we get this. On the y-axis, the highest point is 2, the lowest point is -2, hits everything in between. So we have to write it like this. This is not a function. Now, if you have a graph, you have one other option. It's called the vertical line test. If it fails the vertical line test, you can use that as your reason. Only if you have a graph, not if you have a list of points. So it fails the vertical line test. Now on that second page, 249, 3 through 8. So 3 lists a table and you have to come up with the equation. Well, the equation will be y equals x minus 2. If you plug in any of those x values, you get back the given y value. 4, okay, you got, and I'm going to put this as in an xy chart. You have the point 1, 4, 2, 7, 3, 10, 4, 13. This is a harder one. It's not as obvious. Well, one thing here is if you have a pattern, it goes up 3 every time. What that means is there'll be a 3x in the equation. Well, that doesn't work exactly because if you take 1 and plug it in for x, 3 times 1 is 3 and not 4. 3 times 2 is 6 and not 7. So to get the number we need to add 1. So our final answer will be y equals 3x plus 1 for that one. For 5, okay, identify the independent and dependent variable in each situation. All right, independent, a small size bottle of water costs $1.99 and a large size bottle of water costs $3.49. Okay, the independent is going to drive the dependent. Well, the independent is the size of the bottle of water because what does that control? It controls the cost of the water. Okay, so the independent is the size of the bottle, cost is the dependent. For 6, an employee receives 2 vacation days for every month worked. Okay, 2 vacation days for every month worked. So independent is going to be the number of months worked. Because that's going to control the number of vacation days. Okay, so there's your independent and dependent. And for 7, now we write a function notation rule for each one, which we started talking about yesterday. We'll hit a little bit more today. All right, so for 7, an air conditioning technician charges customers $75 for an hour. Well, independent is the number of hours worked. Dependent is the cost. Well, it's going to be, think of the cost. The cost is going to equal 75 times the number of hours. Well, that's not function notation. The function notation, here's what you're going to do. If I'm going to use h as my variable, I got to write f of h equals 75h. If you use x as your variable, you let f of x equals 75x. Okay, for that. Do not just put c equals. That's not function notation. And now for 8, an ice rink charges $3.50 for skates, and it charges $1.25 per hour to skate there. So the independent variable is the number of hours skated. The dependent variable is the cost. So again, I'm going to let this be f of x. It costs $3.50 plus $1.25 per hour. So that would be our final cost there. Okay, that would be your function. All right, that was your homework from last night. I just want to finish a couple things up from section 4.3 we didn't get to, and then I'm going to give you an assignment that will be due on Monday. We went over a little bit of this on Thursday. I just want to hit it again. Now, an algebra expression that defines a function is called a function rule. We use this notation, f of x. It doesn't always have to be x, f, and x. It could be g of x. It could be g of t.
Your attention, please. Can I have a custodian to please come to the main office or dial extension 2000, please? Thank you.
All right, if x is the independent variable and y is the dependent variable, then the function notation, we read it as f of x. Now, we did this one yesterday, hit it again though. Identify the independent and dependent variables, and then write a rule in function notation. Independent, so we got a fitness center charges $100 initiation fee plus $40 per month. All right, what's going to drive the cost? That is going to be the number of months. So that is the independent variable, number of months. The dependent is going to be total cost. So if you want to let x be the number of months, then the dependent is going to be f of x. So f of x equals $100 plus $40 per month, which is 40x. So that is going to be the equation. Now this isn't, now we're on your guided notes from yesterday. I attached a new one today. If you want to reprint it, I mean, you can start again. Now this one is not on the guided notes in particular. I want to go over this first, and then we're going to do a couple examples on the guided notes. So evaluate, now this is again how function notation works. For f of x equals 3x plus 2, find f of x when x equals 7. That just means we plug in 7 the value, and then when x equals -4. These are two different problems. Here's how they work. Just like I said, just pay attention to this one. So if I want to do f of 7, I make it 3 times 7 plus 2. I do the math. That's 21 plus 2. That's 23. So that means f of 7 equals 23. When I plug in the number 7, I get back the point 23. It's also an ordered pair. Now the second case is when x equals -4. So you plug in -4 for the values, you simplify, we get -10. So f of -4 equals -10. All right, now this is on your guided notes. So let's take a look at this. And I would kind of organize it like I have it here, kind of one on the left and one on the right. All right, it says find h of c when c equals 1 and when c equals -3. Now we've always been using f of x, but we can use different letters here. So for this one, let c equal 1. So h of 1 equals 2 times 1 minus 1. Do the math. 2 times 1 is 2. 2 minus 1 is 1. Okay, so h of 1 equals 1. Now the other case is when c equals -3. So what we do is we say h of -3 equals 2 times -3 minus 1. That's 2 times -3 is -6. minus 1 is negative 7. If you want to use your calculator, 2 times negative 3 minus 1 gives me negative 7. Okay. Now you can think of that as a point negative 3, negative 7. Okay, same idea. Different letters here. Instead of h of c or f of x, I have g of t. As long as if I have t here, that means I have to have t in this equation on that part. So g of t equals 1.5t minus 5. All right, what's that going to be when t equals 6? So it becomes g of 6 equals 1.5 times 6 minus 5. Okay, what is 1.5 times 6? It is 9, and 9 minus 5 is 4. So g of 6 equals 4. All right, over here, t equals negative 2. So g of negative 2 equals 1.5 times negative 2 minus 5. So g of negative 2 equals, what is that, negative 1 minus 5. So g of negative 2 equals negative 6. So that's what you do in this case when you have that function. You substitute it in, see what value you get back. Now this one isn't on your guided notes, but you should have room on the bottom. Okay, pay attention here on how to answer a question. It looks like this. A mail order company charges $5 per order, excuse me, plus $2 per item in the order, up to a maximum of 4 items. That's the most we can order. Write a function rule to describe the situation, and then find a reasonable domain and range. I'll explain as we go further for the function. All right, the function rule is going to describe how much is it going to cost. So if you let x equal the number of items ordered, okay, let's do that. So f of x will be the cost. Well, it's going to be $5 plus $2 for every item ordered. So this is going to be our function. We have to write it like this because it tells me to say write a function rule. I cannot just put y equals, I got to put f of x. All right, now what's a reasonable domain and what's a reasonable domain or range in this situation? Your domain are the number of items you order. The range is going to be the cost of the items. Well, the domain is restricted because I am told I can order up a maximum of 4 items. Well, also, if you think about it, you can't order any negative items. So the smallest number of items you would order is 1. I could order 2, I could order 3, or I could order 4. I'm not allowed to order 5 because it would be above 4. The range now is the cost based upon the number of items. And by plugging it into the function, that gives us a range. So plug each domain into the function, and that gives us the cost. Well, it's going to be 5 for one item. It's going to be 5 plus 2, which is 7. That is one of your range members. Your next item is 5 plus 2 times 2, which is 5 plus 4, which is 9. Now plug 3 into the equation. Gives me 5 plus 6, which is 11. And now plug 4 into the equation, and 5 plus 8 is 13. This is your, quote, reasonable domain and range. Wouldn't want to plug in 5 because I'm not allowed to get more than 4 items. Can't plug in anything higher than that, and I can't get a number of negative items. We really don't need to plug in 0 because if I get 0 items, I'm not going to order anything. So the fewest number of items I'd order is 1. All right, what I want you to do now, or what we want to do now, is complete this assignment. And this is going to kind of give me a gauge of where you're at. And this is going to be worth 20 formative points. and it will be graded, okay, for correctness, not just completing it. So I need to have an idea if you understand this stuff or not. All right, I'm going to give you an answer sheet, or I posted it so that you can organize your work pretty easy. Now, I know it says right here, it says out of 40, basically what I'm going to do is I'm going to scale it to 20. So if you get a 30 out of 40, it'd be a 15 out of 20. Okay. And then here's where everything should go for your answers. Now, to get that, that is going to be, let's see. It'll be listed under the modules. I don't have it on there yet. Okay, but it'll say homework answer sheet. It'll be right there. And if you click on that, it'll pop up. You can print it. Now, if you want to, you can write it out, but this is a little bit easier if you print it on that the answer sheet that I'm leaving for you to copy. All right, best of luck, and I will see everybody on Monday.